All right, welcome folks. You are here for automated policy remediation with Gomboc AI and HCP Terraform. Looking forward to chatting with you today. We'll get kicked off here in just a couple minutes. We'll give folks a chance to join. If while you're waiting here for us to first kick things off, we do have this URL here, tinyurl.com/gomboc-hcp-webinar, and you can set up a Community Edition account with Gomboc and get our Community Edition AI agent skills installed. And a note on that the skills install in not just Claude, but Gemini, Cursor, and Codex. But if you'd like to follow along at home with some of the things we'll be doing here, you can get that set up on your machine. Maybe just one more minute here and then we'll get started. All right, let's get things kicked off here. All right, again, you're here with folks from HashiCorp and Gomboc AI, and we're here to talk to you about being able to transform guardrails to fixes. And the title is an automated policy remediation approach with Gomboc AI and HCP Terraform. And just a quick overview of what our goal is today. So we want to be able to talk about the journey of implementing guardrails with customers like our friends at Upwork using a structured approach from Gomboc and being able to implement that in the HCP Terraform platform with the Run Task integration. And really give a stepwise approach to adopt not just guardrails implementation, but remediation implementation in your organization. And also leave you with tools that enable that transition from maybe being unable to implement guardrails or feeling frustrated by that to being able to actually effectively translate into accelerated deployments while still having guardrails in place. All right, so overall, we're going to talk through who we are, what the environment setup is that we'll be using as we give this demonstration during the webinar here, have a little bit of discussion about guardrails, policy as code, and remediation application, talk through the remediation's gap and use cases, and then get hands-on with HCP and our agent skills from Gomboc to demonstrate how those all come together and talk a little bit about what we're seeing with our customers and the future of what things look like with Gen AI and guardrails application for infrastructure, and then have a little Q&A. And with that, I'd like to introduce a friend from HashiCorp, Adam. Go ahead, Adam.
Yeah, thanks, Matt. Happy to be here on this Gomboc webinar. It's always a pleasure to lean in with a partner like Gomboc. I'm Adam Rowan. I'm a senior product partnerships manager here at HashiCorp IBM. Been here for about 5 years, and I oversee all of our partnerships from the infrastructure standpoint, namely around Terraform, which is the great integration that Gomboc has built with HCP Terraform and the lion's share of what we're going to talk about today. Thanks.
Thanks, Adam. And I'm Matt Sweeney, CTO and co-founder at Gomboc. Really came here to Gomboc with the mission to fix things in customer environments. So been in prior roles leading the security validation, breach and attack simulation product at Google Mandiant and FireEye before that, and then built was a product owner and helped build the SASE solution that became FortiSASE through combination of events from 4V to opaque networks through to Fortinet. But I'll be talking through here kind of the structure of our approach, and then my friend John will be demonstrating a lot of these capabilities here.
Yeah, so I'm John Kamenik. I'm the chief architect here at Gomboc. Before that, I was a staff SDE at Google in the Google Cloud security side of things. I was a director of DevSecOps at Fortinet with Matt at the SASE platform. And then I was a principal DevOps, DevSecOps at 4V, also with Matt. I've been in the industry for a very long time, since well before it was a thing, right? So, we started and we were called release engineers, and then DevOps and SRE and DevSecOps, and my title has changed repeatedly. But yeah, I will be doing the demo of what we've built with our pipeline.
Thanks, John. All right, and just quick before Adam launches in here and kind of sets the stage, just want to make sure that folks wanted to, they had a chance to get set up because we'll be doing a bit of a demo with Sentinel policy and being able to turn that into our open remediation language rules and enforcing that as not only policy but fixes. So take a quick look here and reference the doc that was available at the beginning of the call as well, and go ahead and get set up in the environment. And we'll walk through that a bit when John comes through here. And then also on the run task integration side of things, if that requires actually an enterprise grade account through Gomboc, but for anybody attending the webinar here, if you just email the code hashi in the title to support@gomboc.ai, we'll get you set up with a enterprise account for a month here, and you can go ahead and try this out and test out this run task integration that we'll be walking through during the demonstration. And as far as the demonstration itself, we've actually set up a real live application that's an Apache project, Dolphin Scheduler, so you can play along at home as well. All right, with that, kick us off here, Adam.
Thanks, Matt. So the big reason we're here today, in large regard, is Terraform. But what I'd like to talk to you about before I pass it over to Matt and John to show you the meat and potatoes of what's going on here is really to talk about where Terraform sits and how we like to help you solve your problems. So Terraform's mission is this: to help automate the full life cycle of application infrastructure, from provisioning and governance to security and maintenance across any environment. That's the cloud, that's hybrid, that's on-prem. And provisioning is just the start. If you're getting your infrastructure up and running, your job isn't done from there. You also need to manage it across its life cycle. That includes maintaining, upgrading, and most importantly, securing it. So think IAM permissions, secrets, certificates, database credentials, and so on. You can imagine. You need to make sure secrets remain secure, that credentials are rotated, and certificates are renewed. That's where HashiCorp's broader toolset comes in. When you look at applications across these four systems, HashiCorp addresses the need of infrastructure and security lifecycle management. And we do it all on a unified system called the HashiCorp Cloud Platform. Next slide, please. So let's take a quick step back and talk about the real problem we're solving. In most organizations, teams have traditionally worked in silos. Security has their own tools and processes. Developers are focused on application code. Platform teams are managing infrastructure on their own. Security, is off doing their own thing. And none of these groups are really speaking the same language. That kind of setup creates a lot of friction. If not done right, it can slow everything down. You've got handoffs, miscommunication, inconsistently applied security, and way too much time spent just trying to make things work together. HashiCorp's cloud platform, or HCP, changes that. And we bring two categories of tools to the table: infrastructure lifecycle management, and that's the provisioning, image building, orchestration, and deployment. And then security lifecycle management, which is the secrets, identity, secure access, and service networking side of the house. By combining both, we connect all of these teams through shared workflows in a common platform, so that you're not just doing your own thing anymore, they're actually working together. And this brings consistency across the board without getting in the way of speed or flexibility. In fact, we've seen time and time again that this actually helps teams move faster because now they're aligned from the beginning. We built this to simplify the complexity of cloud operations. No more manual processes or patchwork tools. No more trying to bolt on security as an afterthought. Instead, everything, provisioning, identity, access, networking, is integrated and automated, not just a loose collection of tools. All of these work seamlessly together. And that's what makes this so powerful. You're able to reduce risk, you gain visibility, and teams collaborate better. This leads to faster innovation. And that's the vision of the infrastructure cloud. It's not just about tools, but about transforming how teams work together to build and scale in the cloud the right way. Next slide, please. So I mentioned Terraform, but that's just part of our larger ecosystem. At HashiCorp, we offer 7 core products that underpin what we call the infrastructure cloud. Together, these form a complete system for managing both the infrastructure lifecycle and the security lifecycle, and they give you a practical, proven recipe for doing cloud right. On the infrastructure lifecycle side, we have Terraform, which handles provisioning, Packer, which builds and manages machine images, Waypoint lets you deploy full application stacks with a single command, and Nomad is our workload orchestrator for both containerized and non-containerized applications. On the security side, we have Vault, which manages secrets, certificates, and machine identity, Boundary, which provides secure remote access to infrastructure, and then Console, which enables secure service discovery and automate service-to-service networking. Each of these tools solves a specific challenge in cloud operations, but the real power comes when you're able to use them together. They're built to integrate seamlessly, forming the foundation of the HashiCorp Cloud Platform. Next slide. Ultimately, though, this isn't about tools, it's about business outcomes and solving your problems. By standardizing on infrastructure as code, enforcing security policies automatically, and unifying workflows across environments, you're able to accelerate delivery by giving developers secure, automated paths to infrastructure, strengthening security and governance by preventing non-compliant deployments before they even happen, and optimizing cloud operations and ROI by reducing manual work and friction between teams and making your deployments consistent. This approach doesn't just solve today's problems, but it also lays the foundation for continuous innovation at scale. Next slide. So Terraform, infrastructure as code. That means instead of clicking around your cloud console, you're writing simple readable config files in HCL or HashiCorp configuration language, snippet on the right. So imagine you're building an application with a database and some networking around it. That's a very simple use case. Before you even think about deploying, you need to build your infrastructure, virtual machines to run the application, load balancers for high availability, IAM roles for operator access. It goes on and on. Terraform allows you to declare what this infrastructure should look like, and then handles all of that provisioning for you across multiple environments, whether that's dev, test, or prod, and that ensures everything stays consistent. Terraform is declarative. You define the desired state, and Terraform figures out how to get you there. One major benefit of infrastructure as code is consistency. You're hearing that a lot. When you're provisioning one dev environment or spinning up 10 production stacks, you get the exact same result every time. It's also self-documenting. So if someone new joins the team, they can read the code and understand what everything out there deployed already looks like. Terraform has two main phases, our plan and apply. In the plan phase, that's where Terraform tells you what it's going to do. And then the apply phase is Terraform actually doing it. This makes infrastructure changes safer, reviewable, and auditable. And combined with a VCS or Git, you get a full version history of your infrastructure, who changes what, when, or why. And because Terraform is open and extensible, it uses a vast ecosystem of providers to support nearly every major cloud platform, whether that's AWS, Azure, GCP, and beyond. Any major tool or platform has a Terraform provider, whether it's maintained by HashiCorp ourselves or the platform owner. You can explore these providers at registry.terraform.io and find documentation, examples, and best practices. So finally, next slide, why we're here today and why and how Gomboc fits into this critical piece of our workflow. So over the past several months, there's been a fundamental shift from coding directly to code suggestions. And now we've evolved even to prompting agents and then agentic loops. So what I'm going to do now is pass things over to Matt and John, and they're going to discuss what this evolution means to you and how Gomboc's critical solution and platform helps solve these problems. Over to you.
Awesome. Thanks, Adam. Yeah, I think we are at this critical juncture here as far as what does an engineer do? And in the realm of AI, how do we help accelerate without getting stuck at block deployments when we really want to enforce best practices, standards, compliance? And this is something that we've been solving with our customers as far as, okay, we have best practices and well-documented standards for what, as a customer, I might expect in my deployment environment using Terraform. I think this is like the richness of what exists there with Terraform and, IAC-based deployments and all of the registry and documentation and all of this helps support being able to take that information and transform it into something useful. For instance, you see the 1300 out-of-the-box policies. This is really, Hashi has already invested in Sentinel rules all kinds of coverage across the different cloud providers, being able to describe what best practices might look like. And that helps govern and make sure that you can block deployments if things look bad. And where we come into play at Gomboc is being able to say, okay, let's take those and actually extend that thought even further and go into the realm of automated fixing and bring in context like severity of not making the change and being able to communicate operational risk if you're making this change. And so all of this is relevant metadata that we can use with both in our portal and with agent skills to be able to appropriately understand the work to be done and prioritize it, break it out, and effectively implement it without breaking things in production. And so I think this is and being able to translate all these changes, not just at the last mile right before deployment, but being able to deliver it throughout the SDLC and to be able to say, okay, these are available with my agent when I'm coding or in my IDE plugin or in my CI build or when I'm ready for deployment and with a run task integration, I have full connectivity of what the right thing to do is across my life cycle here. And that's what we're here to deliver. All right. So as far as we'd like to talk a little bit about this gap because I think the what Adam covered actually really well illustrates that the goal is to bring together folks from the different domains of operations and engineering and security from the infrastructure perspective. But there's different challenges and kind of biases and what the person in each role might want to do and look to do as far as how they can communicate what they need. So, the operational concerns are often not in the wheelhouse of application developers. Application developers and platform engineers are looking to figure out how can I support the business and get this new infrastructure deployed, this application deployed. The security team is looking to make sure that compliance and security standards are enforced and consistent across the organization, and they don't have big gaps in the implementation of these standards across the whole organization. And then being able to connect these worlds together, this is really the fundamental disconnect that we see is that the need is to connect all these worlds together and provide really a gate or an accelerant to make sure that these can be implemented because oftentimes the security standard is viewed as a blocker, as no one shall pass unless you meet this standard, and then deployments slow down. And then there's also the and this is I think going into the next slide here really is I kind of got ahead of myself a little bit, but what does it look like to actually have guardrails 2.0 where these worlds are connected and things move smoothly instead of being disconnected. So instead of having security win by enforcing guardrails and blocking deployments and ensuring compliance and then slowing things down, or having engineering win where, win in quotes, that, guardrails are really non-existent and maybe there's some kind of audit level kind of notification about any issues that might exist. But the goal is moving at speed, and it might be more of a, move fast and break things type mentality and fix them fast. In both of these cases, really the organization is what loses because risk is not adequately managed in either case, and you either have to deal with slower deployments and products that can't get out the door, or dealing with operational issues or security issues that leak through and might take, after initial deployment is made, 6 months or more to actually circle back around to and fix. And so, really, this is ultimately the situation we're helping to avoid by saying, okay, you can actually, have your cake and eat it because you can define policy that translates into an understanding in the code that you're using to deploy using Terraform, and then being able to get while I'm either in the midst of building the code or before deployment and things go awry, I get that insight, oh, this needs to be fixed first, and I get immediate action on that. That doesn't slow me down wondering, how do I disconnect or how do I reconnect this operational concern to my code? So I think with the next phase here, what we want to go through is what this remediation journey looks like. So we're going to go through kind of a base state and then a crawl, walk, run type approach to what does it mean to actually implement security operations and engineering operating in harmony with code remediation that's implemented as policy. So in the first step here, we're really going to talk through this base state where you get some level of insight, scanned reports of the code that you can understand maybe in an individual or siloed basis for a particular project or repository what the state is. And then in the next phase, you really get more broad insight across your enterprise and being able to pull all this information together and then being able to intercept pull requests and deployments with clear warnings about what the issues are. So you're able to move from not just some kind of high-level insight into what the issues might be, but being able to contextualize those insights in your code itself. And then on the walk phase, being able to apply some level of governance so that you can have not just the awareness of what the implementation should look like, but actually being able to deliver it. And this involves really, going through these phases involves a level of tech debt burn down along the way too. So I might have one policy that says I need to, use a certain module that I've built for, say, KMS, encryption implementation in AWS. And I might have an audit that shows me what my use of KMS modules looks like across my Terraform code, but I don't necessarily have insight into where any issues are in that. So, next phase, I'm rolling out some policies that say, okay, this is what that should look like as far as my use of provider, customer managed keys, what the key rotation interval looks like, certain specific policies, and then being able to translate that into, okay, I am using encryption appropriately across my enterprise, and I have a bit of tech debt that I've discovered and been able to burn down as a result. And then at the walk phase, I'm now able to say, okay, I've got a policy that I'm generally adhering to. I have awareness of the organization can see when there's any issues with this. And in the last phase where we're running, we're basically saying, okay, now because we've made things consistent, we understand what the expectations and best practices are, we can actually turn this on an enforcing type mode where now I have the ability to uh, effectively get a automated code change or PR automatically created for me and translate from any kind of mistake that might pop up into a near immediate fix. All right. And with that, kind of talking through the overall process here, I'm going to hand it over to John to the terminal uh, for a demonstration here where we'll walk through taking an
Yep.
existing policy and being
Thank you,
able
Matt.
to translate that.
So
All
to
right.
set the stage a little bit, um, we're actually going to use Dolphin Scheduler, which is an Apache project. It's quite a complicated one, but it's a realistic example of what usually application team is going to look for. They're going to look for some sort of thing that a platform team or DevOps would deploy that they can use. So if we look at Dolphin Scheduler, I have the repo open here. There is a
John, I
deploy. Oh,
think you need to share.
are you are you guys not seeing my screen?
Not yet.
Okay.
I see
Let
the
me.
I saw the repo, John.
Oh, okay. I will
Okay.
reshare.
There it
Okay,
goes.
are you okay? Little hiccup there, but so we have the repo. In this repo, which is actually provided by the Apache Foundation, there is a deploy. And in there, there's several ways to deploy it. The one we're interested in is Terraform. They only provide an example with AWS, but that's the one we're going to look at. Now, you'll notice there are Packer templates. For this demo, we're going to skip that. But again, this would be you set up CI, build your Packer templates, their AMI images, and then you would do this Terraform stuff. But as you can see, there's quite a lot of Terraform in here. And it's 4-ish years old. You would think that's stable. However, as most quick starts are, this isn't really scanned, right? So you're going to hand this to your platform team. They'll probably set it up in a lab for you. Things might be fine. They might go to staging, and now all of a sudden, in your base state, you're getting these alerts that something's wrong. So we're going to pretend like we've deployed this into staging, and we have a ticket that was thrown over the wall by security that basically said it violated one of the Sentinel policies that we have in place. In particular, that Sentinel policy is protect against RDS instance deletion. So if we look at the Sentinel policy, what you can see is it's a generic language for reading the plan JSON and then looking at various attributes. So in this particular case, if on these instances, this attribute is not set correctly, i.e. it's false, then generate a violation and cause a failure. And that's great. It tells us there's something wrong. This isn't a simple case, so this is what we're going to use, but let's pretend, for instance, it was a more complicated case of, you needed to do multiple things. Just having a warning isn't necessarily the best thing. So being able to turn this into a remediation that you can then apply across many repos. So anywhere you have an RDS instance that might have this problem, it can just get fixed is what we're trying to do. So the first thing we're going to try to do, are you guys seeing my editor? Since we had sharing problems last time. Okay. So what I've done is we provide a bunch of skills for your AI agents. Like Matt said, they work in all the major agent harnesses, I guess is the term. So what I've done is I've checked out a fork of this. It's the Dolphin scheduler on the branch Hashi demo. So it's a clean branch. I kicked it off, and now I've done this earlier in the day because some of the turn can take a while, and I want us to get through this. So one of the skills we provide is convert Sentinel. So at this point, as Matt has mentioned, Gomboc actually monitors a lot of these Sentinel rules and automatically generates them. But we're going to pretend like we don't actually have a rule like this. So what you can do is you can provide it any policy, as long as we can do a web fetch on it, or download a clone of it. It can be a local path if you have that. We can read that, figure out what it's trying to do, and the important part is Sentinel works on the plan. We work on the source code. So we actually have to do a back translation from what a plan would look like to what the underlying source code would have to be to represent that. So in this particular case, we're doing a zero context fix. The first thing our skill has to do is it has to make realistic versions of all of the cases. So it's actually creating various AWS database instances with, data protection is correct, data protection is missing, data protection is explicitly wrong, and so on. And it does that so that it knows whether or not the rules are going to work. So it also will do various different versions of that, formatted strangely and not. Once all those rules are done, once all those cases are done, it builds the rule. So our rule is a YAML-like syntax, which has a name. It has a display name, which you'll see in the UI in a minute. And it has basically a bunch of rules internal to it. So what we're going to do is we're going to see, after it has generated the rule, it tests the rule. Built into ORL, which is the language and tool that we have defined, is a testing tool, a testing subcommand that can actually run these against your workspace. And so now what it's saying is, okay, what we've actually done is created two scenarios, one where it's true or it's missing and it needs to be true, and one where it's false and it needs to be true. It generates a package that looks like this. So we can see that there is a ORL rule, a test ORL, which is the test case, and then all of the cases. It gives you the link to where that file is. And because I actually had a rules service token that I generated from the site, it asked me if I wanted to upload this automatically and make it available to any workspace. In this particular case, because it's a demo, I've said no. But let's go ahead and look at the fully rendered rule. So this is a power user tool. So when we get into the grammar, you'll see that the grammar is based on compiler parsers, right? It's a AST and S expressions to traverse the tree with some helpers. But before we get to that, it's important to know that we provide a bunch of metadata. That metadata is used in our product, as well as in PRs and various places to see how the rule actually behaves. So when you create a rule by default, it's pretty light in metadata. So in this particular case, it just has a description of what this rule does, and it has a classification, and it pulls from one of the 1,300 classifications we already have to try to figure out where this would sit. And we'll show that later. There are other annotations that you can provide that are not checked really, but they can add information to the system, like a plain text description, which is this is marked down, this is plain, and there are plenty others. When we look at the actual rule, this is the S expression for traversing the AST. So it's taken the code, it's turned it into an AST, and then what we're saying, and this looks very similar to the Sentinel policy, is go find AWS DB instances, and then two cases. One where an attribute value, this attribute, is not true. So anywhere it finds that, it represents a finding. Each finding is then remediated. The way it's remediated is it's going to replace the value, right? So this part with true, right? So it is not equal to true. So it could be any string or expression really, and it's going to make it true. This one's a little bit more complicated because what it's doing is it's saying anything where there is no attribute called deletion protection, we have to insert in the tree a new item, but we have to insert it as text. And so we will prefix it with an empty line because this slurps the new line character. So we insert two empty. We insert two empty. Where were we? Two empty new line characters to get one blank line, and then we insert this text. Now, when I looked at this rule, I don't like this prefix. It's generating that prefix because I work at Gomboc, and so I'm using a Gomboc token. But for the demo purpose, I want it to have Hashi demo. And that's going to help me tell later what are rules I generated versus what are rules I pulled. So here you can see, okay, boom, I pulled that. Also, this was in there for some reason and it fixed that. Moving on, since I'm in the directory, I can say, I want to apply this rule to deploy Terraform AWS and see what it does. So it's going through the skills that we provide, figuring out how it can apply the rule. And then it applied the rule. And I know that is correct, but I don't know if it did anything. And so I just run a git diff. I see it was what added this. So now I can close that ticket. I can submit a PR for this and do that ticket. That's kind of the base state. That's where you get, where you're going to integrate, where you have existing SSDLC. So we want to step up a level and kind of go towards the crawl. What we really want to do is add metadata to make this a real rule that other people can use. So we have this add metadata rule. It's going to collect a bunch of sources and it's going to try to enrich that metadata. So we're going to skip through a bunch of this and we can see, okay, there's a bunch of patches, but they're collapsed. So now it prints all the metadata it added or updated. And this is good information to have. So like classifications, in addition to the one classification it found, there's a data protection. There's also a CIS standard. So if your company uses CIS, you can basically say, hey, I care about the CIS standard, and this rule would be associated with that standard and would automatically get applied. We can also see that it's a full remediation. That's great. It fully remediates. There's no, hey, it's a partial remediation or it's a remediation that requires manual input. It's a full remediation. The risk of not doing it is high. The impact of doing it is high, right? And then we can see that it came from this Sentinel, right? And so then you can see what it looks like in the actual YAML, which is, again, this annotation can be marked down. So it can be as big as you want. And then we like to put a plain text version on there as well. We also generally provide examples. And this can be pushed straight to our product. So now we're in the walk phase. I'm going to jump back over and I'm going to show our product. So we're going to log in here. Let me switch us to the demo account. When you log in, you see what scans you've seen, what scans you've done, and what you can do. You also have the option to integrate it with any of your existing source version control systems and run task integration. So in our particular case, we have it connected to GitHub. It does a scan of all of what we call them workspaces. This is going to be very similar to how a Terraform cloud workspace works. So in our particular case, or Dolphin Scheduler dev branch, deploy Terraform AWS has findings. We can look at the findings and we can see, so I generated one based just off RDS. But I can go here and see what Gomboc already has for this that I might be able to fix. So generally, let's say we care about high and critical. Okay. So no critical, but a bunch of high. And we know that the medium and lows are, okay. The medium and lows are the ones that are easy to fix. So here we see we should have IAM database authentication enabled so that you don't have to manage passwords. It's not, but that would be the diff. Here you can see our instances really should be disabling the V1 version of the metadata API and only allowing the V2 version, which isn't default still in AWS, even though it's been vulnerable for years. If these are things that you don't want, you can create an exception. You can apply the exception to a policy set or to just an individual workspace, and they get taken out. Or you can do what we're about to do and set up sort of a series of policies and start walking. Okay. But for now, we're not going to do that. What we can do instead is if these are all easy, we can check them all and say deliver fix. What this will do is it will create a PR that represents just that change in the remote repo. So if I don't have any PRs for that, but it would. Now I'm going to jump to the walk stage, right? So assuming we get this all set up, one of the things that we can do when we walk is kind of set it up as a triage of not, hey, I need to be perfect right now, but I have a realistic plan to get to enforcing. Okay, so I've loaded a session already. Same workspace. But now what we are going to do is use our diagnose skill. Okay. And we're going to give it the same directory as we did before. And what that diagnose skill does is it reads all of the policies or all of the classifications and policies from the server, tries to apply them, and it gives you a table of everything that it thinks is wrong and whether or not you have a rule for it or whether a new rule needs to be created. So in this particular case, you can see we've disabled a bunch of rules, and so there's a lot that would be created, but many of these already exist and wouldn't normally need to be created by you. But it also tells you, okay, here are the frameworks that we cared about, right? So we looked at CIS controls, NIST, CSF. We even looked at checkoff for what might be wrong. Provides you full detail, full visibility into what's wrong, and then says, hey, what do you want to do? Now, I don't want to fix everything right now. Instead, what I want to do is using operational risk, I want to put things into buckets, right? These are the things that I can apply now and things I should do later. This skill is capable of doing that. So what it's going to do is now it's going to add the operational risk, and it says, oh, okay, these are low, we can probably apply them, just like I did on the UI. These you should schedule. These you really need to have architectural change plan. So this is a public repo that people use as a template, and we can see that there are things like, routing to the public internet come out of that. It's also going to show you a nice little mermaid chart if you wanted to copy that and paste that. But you get this quick summary. It says, what do you want to do? Because we annotate our skills, you can go, hey, I just want to apply the low-hanging fruit and create me a list for next sprint and next quarter. Okay, here we go. We're just going to apply these. It knows what needs to be done. It knows what needs to be done. It can just churn through all of them, gets through them all, says, okay, the low-hanging fruit is done. We can run tests. We can give you notes, and we can give you things for the next quarter. And so basically at that point, you can choose what to do. So now let's assume that we've put all this in the backlog and we've burned it all down. Okay, so what are we going to do now? We're going to go back in here and we're actually going to turn on run task integration in enforcing mode. It can be in suggestion mode. We have this run task integration. You just give it a name. It gives you 2 bits of information. One is a HMAC key, and one is the webhook. You can come over here to your repo, go to run task. You can set up your run task. In this particular case, we did mandatory for our demo. So this is blocking. Now, what'll happen is if we go back and we go to our runs and we look at one of our runs, we get a pre-planned failure with a link back in to that scan on this workspace, 83 fixes. You can just deliver them all, or similar to what I showed before, you can pick and choose what you want. You can even ask for exceptions. When you do an exception or when you deliver a fix, another plan will happen, and eventually you will be unblocked from pushing. And I believe with that, Matt, I'm going to turn it back to you.
Thanks, John. All right, and at this point, I'm going to walk through a little bit of kind of going to the next step of run. And in the Gomboc enterprise skills, which I will show here in our, this case, in cursor agent. Second here. I'm going to walk through applying guardrails to a the AWS Terraform module for S3 buckets. So this is something that I picked simply because it's part of the Dolphin scheduled deployment, but you could take any Terraform module. We've already built hundreds of rules around these guardrails, but as Adam mentioned earlier, a lot of the Terraform modules are really nicely documented. They have examples, best practice guides, all kinds of information in there. And so we built a skill for the agent that will basically say, okay, I want to create some new guardrails around this particular Terraform module, use a particular version, and what this skill will do is create all of the policy items, which we call classifications in Gomboc, and then uh, walk through creating rules and also find rules that already exist. So I ran this initial command here, which looks like this in Cursor Agent. In Claude, it'll just look like /guardrails as a command. And then it actually sets up a campaign to track doing this. So this is, someone who might sit down and do this might be a security architect or a platform engineering architect who's really the champion for proper implementation of the infrastructure. You can have the ability to sit down, define particular guardrails. You might already have, as the case with some of our customers, they had wiki pages internally that documented, oh, this is how this should be implemented. You can take all that knowledge that already exists and then translate it directly into implementation that helps the engineering team properly implement the infrastructure in a consistent way. And so, what rather than execute this live, I did this a little bit in advance here just to kind of walk through what happened. So, we started out a new campaign here for building guardrails. It created a set of classifications, which is John was showing earlier. Those end up on the rules as annotations to say, okay, this applies. This rule applies in the context of this policy item here. And then each of these changes was tested against example code and different types of scenarios where there was different configuration missing or needing to be changed were created. So we've got in the context of these skills tools that help us to give the agent the ability to walk the code, run tests, and ultimately remediate the code, all with very discrete feedback around where those locations should be in the code, specific languages with S expressions or EXPR language for being able to express how to query the syntax tree of the code, and then make sure that the exact changes that are needed are made so you don't get any more or less than what you want in the fix or the guardrail that you're implementing. So in this case, and you can see here along the way, like different tests being run, artifacts being produced, and then what we get here as output is, okay, we have a particular directory where we've created the guardrail definitions as policies, and all of these apply to S3 buckets. I have some existing policies that were already there that were mapped into this world here because there were existing CIS standards, NIST standards, things from Prism Cloud or Checkoff policy that existed. So those are already mapped in, and then we created 5 new ones. So being able to create bucket owner enforcement, avoiding destroy, force destroy, etc. And you get a kind of a summary report of what was done with the agent skills. So when I initially told it, I told it to just build one rule, so it did. And another thing that I did was say, you know what, take what you did here and build your own golden template based on all of the guardrails so that you have an implementation example, which we'll look at in 1 second. And now I can not only have all the rules that will take existing implementations and update them to this standard, but I have an example implementation that I can use and say, use this for any time where I see an AWS S3 bucket mentioned, actually expect, and recommend this to an engineer to use. And then as far as so I scroll down a little further here, the overall outcome. So the golden module was implemented, and then I ran so we have 18 new findings related to this golden template, and now I did a dry run against the directory there in Dolphin Scheduler, applying these guardrails, and it created a dry run diff of the code presented to me here, saying these are the changes that would be made in order to enforce these guardrails. And so now I've had, from just that one initial command, I get a base set of 15. And I can tell it to do more, but kind of cap it at initial set just to start in a reasonable place that we can digest. You can see what those look like, map it into the existing ones that are already in the Gomboc universe, see what the application of that would look like on your code, and then say, okay, this looks good. I want to, enforce this generally as a golden module, and also I want to apply it to this code, and I can go ahead and do that right away. So, and then let me switch sharing real quick here, and then we'll wrap up with some Q&A. So here, as far as some of the snippets that were created here, I actually have golden modules for the baseline hardening, what a log bucket looks like, and what a production bucket configuration would look like here. So along with that, all of the rules that were created, and I can release all these into just my tenant in Gomboc and enforce policy. We also, take submissions and generate our own rules all the time for broader consumption by our customers. So that's pretty much it. With that, any questions? Well, let me just reshare so you can see our contact info here. So all folks who attended today, you'll get a link with a copy of the recording here. If you didn't get a chance, you can just visit gomboc.ai/community to get access to our community edition. And as I mentioned earlier, if you submit an email to support@gomboc.ai with the title Hashi, or in the body saying code Hashi, we'll get you hooked up with access so that you can try all this out. And we also have in our Gomboc AI Rattleback insecure by default configuration examples, a bunch of scenarios. It's actually in Rattleback/scenarios folder. There's 15 different examples of Terraform configurations or remediations that you can test applying using the Gomboc community skills as well, just to see how all that works. So um, with that, thank you very much and have a great day.
Thanks, everyone.